Hello friends, now we are going to start new topic or new course, that is IOQM, and this topic or this course consists of several parts of the mathematics like algebra, geometry, basic mathematics, okay, number theory. So now one part of IOQM, the questions coming from this topic, that is number theory. It is one of the basic or the strongest pillar of mathematics and most interesting chapter in the whole syllabus of RMO, pre-RMO, IOQM, International Mass Olympiads, ISI-CMI. In all cases, in all competitive exams, number theory is one of the important and most interesting topics. Okay, now. So now, without wasting our times, we are going to start the topics. So first topics I am taking is divisibility. All of you know about the divisibility. So now going for the definition of divisibility. What is divisibility is? So first of all, we are going to define the divisibility rule or divisibility definition. What is divisibility? An integer b is said to be divisible by a non-zero integer a if there is an integer x such that b is equal to ax and we can write a divides b. This symbol is the symbol of divisions. We read in this way: a divides b. In case b is not divisible by a, we write a does not divides b. A does not divide b. Okay, na? So this is the definition. So when we are going to divide one integer by another non-zero integer, so there should exist a unique integer x such that we can write b is equal to ax, and we write in the notation a divides b. If b is not divisible, then we should write a does not divides b. Take examples. All of you know that 2 divides 10, but 2 does not divide 11. 2 does not divide 11. So when 2 divides 10, so we can write 10 is equal to 2 times of something. That something integer is 5 here. Okay, na? So this is the basic definitions of the divisibility. That means when we are going to divide one integer by another integer, then there exists some whole number. Then there exists some integer we call that integer as x or the quotient q, such that we get the remainder 0. Okay, now from here onwards, when we write in this way, suppose AB, then whole bar, it indicates that I am talking about the 2 digits number 10A plus B. If I write A, B, C, then this is a 3 digits number 100A, then 10 times of B plus C. If I am taking A, B, C, D, so this is a 4 digit number, so it will be 1000 A, 100 B, 10 C plus D. If I am taking A, B, C, D, E, so it is a 5th digit number, so we can write 10,000 A plus 1000 B plus 100 C plus 10 D and then E. So this is the concept of divisibility definitions. Next point, we are going to describe divisibility rule. Divisibility rule. Okay, now. So point number 1, rule for 2, 2 square, 2 cube, 2 power 4. So like this. What is the rule for divisibility by 2, divisibility by 2 square, divisibility by 2 cube and divisibility by 2 to the power 4? So now a number is divisible by 2. A number is divisible by 2 if the last digit of the number is divisible by 2 power 1. Similarly, a number is divisible by 2 square, that means by 4, if the last two digits of the number is divisible by 2 square. A number is divisible by 2 power 3, that means 8, if the last 3 digits of the number is divisible by 2 power 3. A number is divisible by 2 power 4 if the last 4 digits is divisible by 2 to the power 4. Now the question arises, why this rule is working? What is the reason? What is the logic behind it? So now consider some examples. So now consider any 2-digit number or 3-digit number 1, 1 and 2. So what we say that if the number last 2 digit is divisible by 2, then the whole number is divisible by 2 square. Okay, now if the last 2 digit is divisible by 2 square. So first of all we detach 12 from the 112. So it will be what? 100 plus 12. So now we can write this number 100 is always divisible by 4. So this is divisible by 4. So only the problem is about these digits. If it is divisible, then this is also divisible, sum is also divisible. So now if you have 113, so what will happen? We can detach in this way, last 2 digits, so it is 13 and the remaining is 100. So this number is divisible by 4, but this one not. So therefore whole number is not divisible by 4. You can take another example also. Suppose 1, 2, 3, 4 and 5. So now you are checking what will happen to the last 2 digit whether it is divisible or not. To detach this 2 digit, what will happen? 1 2 3, now this become this one. So what we know that all this part is divisible by 4. There is no problem because last 2 digit is 0, so obviously divisible by 4. So what will happen based on this? If it is not divisible by 4, then 4 does not divide this number. So that is the reason it is working. If the last digits are divisible by 4, then the whole number is divisible by 4. Same thing happen for the 8 also. Same things happen for the 8 also. So if you have this number 1 2 3 4 5 and 6, so now you are checking whether it is divisible by 8 or not. So last 3 digit you have to detach. So what will happen? 1 2 3, after that you have 3 zeros, then 4 5 6. So you know that this number is always divisible by 8. This number is divisible by 8 because last 3 digits are 0. So what will happen to this number? If it is divisible by 8, then the total number is divisible by 8. So now what will happen? We check it divisibility. So 5 into 8 40, then yes, 5 into 8 40, 5 and 6 other happen. Yes, it is divisible. The whole number is divisible by 8. So this is the rule. I think hope you understand this logic. I think all of you understand this logic. So now we can generalize in this way. So if I have any 4 digit number, so it is happened for any n digit number also, ABCD 4 digit number. So what will happen? It is A times of 1000, then B times of 100, then you have C times of 10, and then you have D times of 1. So this number is divisible by 4. This is also divisible by 4 because 100 present as a product. What will happen? Now depends on this quantity. If it is divisible by 4, then the whole number is divisible by 4 also. Now this is the rule for divisibility of 2, 2 square, 2 cube, 2 to the power 4. Now we generalize another rule. Point number 2. Rule for divisibility rule for 5 power 1, 5 power 2, 5 power 3 and 5 power 4, like that. So all of you know that if a number is divisible by 5, then the last digit of the number is divisible by 5. Same things happened here also. So a number is divisible by 5. A number is divisible by 5 if the last digit of the number is divisible by 5. Same as rule of 2, 5 to the power 1. So a number is divisible by 5 square if the last 2 digit of the number is divisible by 5 square. A number is divisible by 5 power 3, 5 cube, if the last 3 digits is divisible by 5 power 3. A number is divisible by 5 power 4 if the last 4 digits of the number is divisible by 5 to the power 4. That means divisible by 625. So why it is happened? What is the rule working behind it? So consider one case. Suppose if you take 125, so this you can write as 100 into 1, then you have 2 times of 20, 10, then you have 5 times of 1. So you know that here since 10 present, so it is divisible by 5, so it depends on the last quantity. So if a number is divisible by 5, it depends on the last digit is divisible by 5 or not. Now if you take here this number 4 3 2 2 and here 7, so what will happen? This 4, after that we have 1 2 3 4, then 3 times of 1 2 3, then 2 times of 100, and then we have 2 times of 10, plus 7. So you notice that this number is divisible by 5, this is divisible by 5, this is divisible by 5, this is divisible by 5, but this part is not divisible by 5. So as a result, whole number is not divisible by 5. Okay, now so you can generalize this rule as A, B, C, D. For any fourth digit number, we can have 1000 times of A, which is divisible by 5, then 100 times of B, divisible by 5, 10 times of C, divisible by 5, because 10 has a factor 5 and 2, and the 1 times of D. So if this last part is divisible by 5, then the whole number is divisible by 5. So 5 divides A, B, C, D if and only if 5 divides D. I hope all of you understand this concept of divisibility by 5. Next is divisibility rule for 3 and 3 square. Rule 3. Rule for divisibility rule for 3 and 3 power 2. So here a number is divisible by 3 if the sum of the digit is divisible by 3 power 1. A number is divisible by 3 square if the sum of the digits is divisible by 3 square. So why it is happened? What is the reason behind it? So consider one generalized case, A, B, C, D I am taking. So this number I can write as 1000 A, 100 B, 10 C plus D. So this number I can write as 999 A plus A. So I am writing A here. 99 B, then we have 1 B, then we have 9 C plus C, and then we have 1 D. So this D I am writing here. So this thing we have, and here we have this part. Okay, so many pluses sign I have put here. So now these things we have. So now this we have plus this we have. So here you notice that in the first bracket we can take 9 common. So if you take 9 common, so you are getting some integer. So it is 9 times of some m we can say plus sum of the digits, plus we have sum of the digits. So now we can say that 3 divides A, B, C, D this number if and only if 3 divides sum of the digits, because 3 already divides 9m, so only the left part is this one. 3 divides sum of the digits. Similar argument you can put for the 3 square. So 3 square divide A, B, C, D this number if and only if 3 square divides sum of the digits, because first part is divisible by 9. So only the left part is sum of the digits only. So if sum of the digits is divisible by 3, then the whole number is divisible by 3. I hope all of you understand this concept of 3 and 3 square. So here we have some similarity. Next rule, divisibility rule for 11. Rule for 11. Suppose we have one number, so x is equal to sum of the digits of even places. Now y is equal to sum of the digits of odd places of that number. If x minus y, its difference, is the multiple of 11, then we can say that then 11 divides that number. So take one example. One, try to understand this rule. Example 1 2 3 2 1. So this is odd place, even place, odd place, even place, odd place. So x is equal to sum of the digits of even places, 2 plus 2, that is 4, and y is equal to sum of the digit of odd places, 1 plus 3 plus 1, 1 plus 3, 1 plus 3 plus 1. Yes. So even places we have this one. So odd, even, odd, even, odd. Yes. 1 2 3, 1 2 3 2 1. Yes. 1 2 3 2 1. Okay. So now here we have odd places 1, odd places 3, odd places 1. So 3 plus 4 plus 5, that is 1. Okay now. So what we notice that this difference x minus y, so we have what? Modulus 4 minus 5, that is also 1. So 11 does not divides 1, so therefore the whole number is not divisible by 11. Okay, now let me check the result once again. Something I think I have done wrong. Let me check. 1 2 3 1 2 3 2 1. If I do the division by 11, so it is 1, then 3. Yes, 11 1 ja 11. 2 we have, yes, 11, 11 2 ja 22. Yes, 1 is the remainder. Okay, nice. So now so 11 does not divide the digit, that number 11 does not divides 1 2 3 2 1. Okay, now so if it is the multiple of 11, then we can say that the number is divisible by 11. Suppose I am taking this number 1 2 1. So here this is odd places, this is even, and this is odd places. So x is equal to sum of the even places digit, odd is the sum of the not odd, y is the sum of the odd places digit. Y is equal to 1 plus 1. So here x minus y modulus is difference of these two sum is 0. So you know that which is a multiple of 11. You know that which is multiple of 11. Multiple of 11. So therefore we can say that 11 divides 1 to 1. So why this rule working? What is the reason behind that? Take one example, general cases. I am taking this 4 digits number. So this I can write as 1000A plus 100B plus 10C and then D. Now 1000A I want to write in this way, 10. This 10 I am going to write 11 minus 1 and then multiply with 100. So this will be 11 100A minus 100A. So this 100A again I am going to do the same things. 11 minus 1 10, multiply with 10, so that is 100. So 11 100A minus 110A minus plus 10A. So this number again I can write as this is 11 110. Here 110 110A, then this number I can write as 11A minus A. Okay, now so now these things so we write it again, all the numbers, this A B C D whole numbers we can write as this is for 1000A we write this one. So this one for 1000A. Now 100B, representation of 100B we know from here, which is this one. So this will be 110B minus 11B plus A. Okay, now not A, it is B, sorry, it is B. For the last number, for the this number 10c, we can write as 11c plus 11c minus c. Then we have d. So now if we add, so we are getting what? A, B, C, D. Only just we represent in terms of 11, so it will be what? 11 times of 100a minus, from here if you take, so it will be 100a. Now here plus is there, so plus 110b, then again a, from here you are getting a, from here you are getting minus b, and if you take 11 common you are getting c, and then what we have minus a plus b minus c plus d. So here this whole number is divisible by 11. There is no doubt this number is divisible by 11. So if I say this number is 11 times of m, then whatever this one is nothing but sum of the even places. One is b, other is d. So now we can write x and then y. If you want, you can take the modulus. So here we have this difference x minus 1 modulus. If I call this is, give the name difference, so difference of sum of the even and odd places. So what we have, 11m plus the difference. So you know that this 11 divides a, b, c, d, this 4-digit number, if and only if 11 divides this difference, that is 11 divides x minus y modulus. So now here this part is divisible by 11, so there is no worry about it. Okay, now there are also some rule for divisibility like 7, 13, 17, 19. So these I basically want to give you as a homework. Try to find out rules for divisibility rules for 7, for 13, 17 and 19. Here I am describing some rule because this rule follows some logic like 2 square 2 cube. So that's why these are very important in the exam point of view also. These are very important. So that's why I described here the importance rule and how we apply in the problems. So now we are going to solve the problem. Okay, so few problems we are going to solve on the base of this theory. Problems, and all of you know about my website. From that website also you are getting all these videos and the content absolutely free. Maths Academy, mathsacademy.org.in, mathsacademy.org.in. This is our official website, Maths Academy, mathsacademy.org.in. So from here you are getting everything without any payment. You will get all the things from here. Okay, and I have the YouTube channel. From my official YouTube channel you can also download anything. So now we are going to solve few problems. Before solving the questions, one important result I want to discuss here. So dear friends, I'm going to discuss one important result, then after that we will do the problem. So one important result, this says that if a is not equal to 0 and a divides a number m, integer m, b is not equal to 0 and b also divides the integer m, where SCF of a and b is 1. If it is happened, condition 1, condition 2 and condition 3. If 3 happens, then we can say that, if it is happened, then we can say that product of a and b divides m. For example, 2 to the power 3 divides some number m, 5 divides some number m, where SCF of these two number, 2 to the power 3 and 5, their SCF is also 1. So this will imply, since it is happened, so this will implies 2 to the power 3 is nothing but 8, 5 into 8 40, so 40 divides m. This is the important results. Okay now. So now on the basis of this theorem we have to solve few questions, and whatever we have done here. Question number 1. If 6 2 6 8 4 xy is divisible by 40, find the pair x and y. Find the pair x and y. So now, first of all, the number is divisible by 40. So the number is divisible by 40 if and only if it is divisible by 2 to the power 3 and 5. So if the number is 2 to the power 3 divides that number, if I call this number as alpha, so since 2 to the power 3 divides alpha, it will implies that alpha is an even. Alpha is an even number. So alpha will be even number. So now y can take the values 0, 2, 4, 6 and 8. Since alpha should be an even number, so unit digits either 0, 2, 4, 6 like that it will happen. Okay now. So now what about y? So now again y, alpha is an even number. Since 2 cube divides, so alpha will be a even number. So we have here again what we notice that 5 also divides that number alpha. So now if 5 divides the alpha, then y will be what? Y will be either 0 or 5. But you notice that 0 is the common. 0 is common value. Okay now. So 5 is not the even number, so we can't take this one. So what we can take in the place of y? 0 only. So but we want to say that the number is divisible by 40. The number is divisible by 40. So last 3 digits, since the number is divisible by 2 to the power 3, so last 3 digits should be divisible by 2 to the power 3 according to our divisibility rule. So that means 4. Here we can put in the place of y 0, but we don't know here what will be the value of x. We don't know. But this number is divisible by 2 to the power 3, that means 8 divides that number. So what we can take? We choose all the possibilities. So we can take here x value 1, then we have 4 0, then we have 4 0, then we have 4 0, then 4 0, 4 0 like that. So 1 2 3 4 5 and 6. So 6, then we have 7, then we have 8, then we have 8, then we have 9, and finally we have 0. So check one by one. So if it is not, 410 is not divisible by 8. 420, 5 into 8 40 20, not divisible by 8. Now 430 is not divisible by 8. 440 divisible by 8. Then not divisible, not divisible, not divisible. This one is divisible by 8. It is not divisible by 8. It is divisible by 8. So what we have, the x and y pair we can take in this way. X is 4, then x can take 8, then x can take 0, y is 0, y is 0, y is 0 every time. So our order pair is 4, 0, 8, 0, and we have 0, 0. These are all the possibilities of this pair. So how many pairs are there? Only the 3 pairs. Next question is question number 2, that says that this number, the number 3 y 6 y 2 is divisible by 4. Is divisible by 4, find y. Okay now. So what we know that about the divisibility rule for 4? if a number is divisible by 4, then the last two digit of the number should be divisible by 4. So last two digit we have to concentrate on this part, y and 2. This number should be divisible by 4. So now we can put the values of y randomly: 1 2, 2 2, 3 2, 4 2, 5 2, 6 2, 7 2, 8 2, 9 2, and then we have 0 2 also. Okay, now so 1 2, this is divisible by 4, not divisible by 4, divisible by 4, not divisible by 4, divisible by 4, and not divisible by 4, divisible by 4, not divisible by 4, and divisible by 4. So these are the possibilities. So y can take the value, y can take 1, then 3, then 5, then 7, and then 9. 1 3 5 7 9. These are the possibilities that y can take. Okay, now next is question number 3. Question number 3 says that if 7 1 3 E F 5 is divisible by 125, find E and F. Find E and F. Okay, now so since this number is divisible by 125, but we know that last three digit of the number must be divisible by 125. So this number will be divisible by 125. So now 125, we can take the multiple of this number. It is 125, then it is 250, then it is add 125 375, then add 25 400, then it is 500, then it is 625, then 750, then we have 875, then 900 and 1000, which is not required. So here unit digit must be 5. So we can't take this one, we can't take this one, we can't take this one. So you notice that possibility of E is 1, then F is 2, possibility E is 3, then F is 7, possibility of E is 6, then F is 2, possibility of E is 8, then F is 7. So these are the only possible values which they can take. Okay, now coming to the next question. So this type of very simple question they are asking in the exam. Now coming to the question number 4. This question says that what is the greatest 3-digit number that is divisible by 6? So we have the number, suppose 99, and here I am taking x. So now since the number is divisible by 6, we know one formula is there, one theorem is there. If a divides m and b divides m and SCF of a comma b is 1, then product of AB must divide m. So since 6 we can write as product of 2 and 3, where their SCF is 1. So this will implies that 2 divides that number. If I call this number is alpha, so 2 divides alpha at the same time and 3 divides alpha. So since 2 divides alpha, so number alpha must be even. So if alpha is even, so therefore x, this will imply x should be even. X is even. So now since x is even, the possibilities of alpha are 990, 992, 994, 996, because these are the even number, 998. So now since the number is also divisible by 3, so rules of divisibility is sum of the digit must be divisible by 3. So 9 plus 9 18, divisible by 3, 20 not divisible, 22 not divisible, 24 divisible, and this is not divisible. So what we see that here we notice that this number 990 and 996. So out of these two, 996 is the greatest number. So this will be the 3-digit greatest number which is divisible by 6. Okay, now this question says that if 2575D568, this is a 8-digit number, this is 8 digits number, and if this number is divisible by 54 and 87, then find the value of D. That means both the number 54 divides this number. If I call this number is alpha, so 54 divides alpha, at the same time 87 divides alpha. But now 57 is nothing but 27 into 2. That means we can write 3 to the power 3 into 2 divides the number alpha. So according to the theorem, the 3 to the power 3 divides alpha, and at the same time 2 divides alpha. So therefore the alpha should be the even number. Obviously 8 is present here at the end of the number, so alpha is even, and 3 to the power 3 divides the alpha, and here we have 3 into 29. 3 into 29, their SCF is also 1. So this we can say that 3 divides the number alpha, at the same time 29 divides the alpha. So if you are taking the intersection of these two parts, the number will be divisible only when we can say that the 3 divides the number alpha. So since 3 divides the number alpha, so that means 3 divides sum of the digits. So sum of the digits is what? If you add this number, 2 plus 5 7, 7 plus 7 14, 14 plus 5 19, 19 plus 5 24, 24 plus 6 that is 30, 30 plus 8 38. So 3 divides 38 plus D. What should I put here so that the addition, the number will be divisible by 3? So if I put here 0 is not working, 1 2 3 4 5 not working, 6 not working. If I put D is equal to 7, now it is 45, and this 45 is divisible by 3. If I put 8 not working, 9 not working, 0 already we checked. So what we are getting here, D should be 7 only. I hope all of you understand this concept. Now the question number 6 says that if A and B are the digit such that this product is divisible by 36. So now prime factorization of 36 says that it is 2 square and then 3 square, where 2 square and 3 square has the SCF 1. So we can say that this product, if I call alpha, so we can say that 2 square divides alpha, at the same time 3 square also divides alpha. Okay, now so this is the rule that we know. So now if 2 square divides alpha, so 2 square divides alpha, that means last 2 digit of this number must be divisible by alpha. Since here 1 present, so this number cannot be divisible by 2 square because it is odd number. So only possibility is that this 3-digit number 25B, this number should be divisible by 2 square. That means this last 2 digits should be divisible by 2 square. Okay, now so now the possibilities, if I put here 25, if I put here B any even number like 0, it does not work. If I put here 252, so now this is working here, divisible by 4. 254, it is not divisible by 4. 256, 256 if I am taking, then what will happen? 256, yes, it is divisible by 4. 4 ones are 4, yes, it is divisible by 4. 25 after 6 what we have? 8. So now 8 is not divisible by 4. 9 we can't take, 0 we are already taken. So now if I put here, so possible value of P's are 1 is 2, other is 6. Okay, now so if case 1, if B is equal to 2, then what will happen? Then we have the number 4A1 as a product into 2, 5 and 2. Now here the sum of the digit is what? 9. So which is divisible by 3 square. So therefore it is independent of a. This whole number is divisible by 2 square as well as 3 square. This number is divisible by 36. Whatever the value of a we can choose, it does not affect. So 0 to 9, that means 10 values we can take. 10 values we can take. So here total number of order pair will be 0 comma 2. A is 0, B is 2, then A is 0, A is 1, B is 2. B is fixed here, only the value of A we have to change. Then we will take A is 2, B is 2, A is 2, B is 3, A is A is 3, B is 2, then A is 4, B is 2, A is 5, B is 6, B is not 6, 2. Then A is 6, B is 2, A is 7, B is 2, A is 8, B is 2, A is 9, B equal to 2, like that. So total here we have 10 possibilities we have. 10 possibility we have. Okay now. Now next is when B is equal to case 2. Case 2, if B is equal to 6, then what we have? 4a1, this number into 2, 5 and 6. So here sum of the number is 6 plus 2, 8 plus 5, 13. So this number is not divisible by 9. The only possibility is this number have to be divisible by 9. So 9 divides this number, 4 plus a 1. This number is divisible by 9 only. Okay now, so this number is divisible by 9, that means 9 divide 4 plus 5, sum of the digit 4 plus 1 5, 5 plus a. So this is a multiple of 9. The only possibility is a should be 4. So if you take a is equal to 4, then it will work. So a is equal to 4 and b is equal to, you are taking 6. So one pair from here you are getting. So we can say that total number of pairs of a and b will be 11. Is it clear? Hope all of you understand this question number 6. Coming to the question number 7. Question number 6 is clear. Very interesting fact, very interesting questions. Now coming to the question number 7. Question number 7 says that the sum of digits of the number, the sum of digits, the sum of the digits of the number 10 to the power k minus 1 is 6057. Find the value of k. Find the value of k. Find the value of k. Okay now. So sum of the digits of this number is this one. So first of all, here k is given as k belongs to whole number, non-negative integers. Try to understand. If I put, if k is equal to 1, then we have 10 to the k is equal to 0, then we have then we have what? K power 0. Okay, I think the restriction is not correct. It should be natural number. K belongs to natural number given. If k is equal to 1, then if I call this number is alpha, then alpha is equal to 10 power 1 minus 1, that means 9. If k is equal to 2, then alpha is equal to 10 power 2 minus 1, that means 99. If k is equal to 3, then alpha is equal to 10 power 3 minus 1, that means 39. In this way, if I put k is equal to like 1000 we are putting, then alpha is equal to 10 power 1000 minus 1, and this will be 9 present. How many times? 1000 times. So now if I have 10 to the power k minus 1, which is alpha, so this is nothing but 9 present. How many times 9 present? K times. They saying that the sum of the digit is given. So sum of the digits we can find sum of the digits is equal to 9 plus 9 plus 9. In this way we have plus 9. How many times we have? K times. So which is same as K times of 9. You know that 4 plus 4 is same as 2 times of 4. 4 plus 4 plus 4 which is same as 3 times of 4. So same way K times of 9. ATQ according to the question, K times of 9 is given as the result 6057. Okay na, like 6057. So we have to find K value. K is equal to 6057 by 9. 7 নং 63, 6 নং 54, 54, 6 নং 54, 6 65, 7 নং 63, 63 2 27, 3 নং 27. The value of K is 673. So this is my first class regarding the IOQM and the number theory. So here I am going to start IOQM parallelly the ISI CMI programs number theory, at the same time Olympiad also. So ISI CMI program and Maths Olympiad program cover this number theory, but IOQM is a little bit easier compared to those. So here the theory is little bit easy. The question is little bit easy. We can solve in the classes very easily. So hope all of you enjoy this. If you have any doubt, if there is any error or mistake, please text me in the inbox and give me the suggestions. How can I improve myself? How can I improve my teaching pattern? How can I improve my Maths Academy's way of teachings? So it will be very acceptable and appreciable if you give me some suggestions. And all my colleagues, friends and the students, thanks a lot to watching my channels. Please share it to amongst your friends and be attached with me. If you have any questions, any doubt, you can ask me anytime. Have a nice day. We will meet in the next video. Till then, bye. Have a nice day.